पुराने जमाने के
टीचिंग के तरीकों से
हमको क्यों पढ़ाते हैं? इट्स सो बोरिंग।
अब वेदांतु देगा प्रॉब्लम से छुटकारा।
हाय किड्स,
समझ आएगा तो मजा आएगा, मजा आएगा तो समझ आएगा।
बेस्ट टीचर्स पढ़ाए तो सिंपल लगे एवरीथिंग।
लीडरबोर्ड्स एंड क्विज़ेस से
Amazing.
learning हो जाए हैपनिंग। समझ आएगा तो मजा आएगा, मजा आएगा तो
Vedantu. Learn live online. To attend a free live class, download the app now.
Hey guys, welcome to Vedantu's JEE channel. This is me, your Suri Sir, and I'm back with another exciting session of the Killer 5. Yes guys, today's session, as you can see it on the screen, is electrodynamics. But what exactly electrodynamics is? It's basically that unit of physics where in the background, electricity as the energy is working in the background. Okay guys, and the chapters which will be included in this unit are everything which is ranging from electrostatics till everything which is related to magnetism. Okay guys, so without wasting any further time, let's jump to the very first question, the first very question of the Killer 5. Okay guys, so what you see it on the screen, it says that there are two identical rings of radius r, both have individual charges q1 and q2 on their periphery, and they are also separated by the same distance as that of radius, that is r. So what we have to do, we have to take a charge small q from the center of one of the ring and take it to the other ring, and we have to find out how much amount of work will be done by the external agent in taking the charge from the center of one of the ring to the other one. Okay guys, so let's try to solve this question. Well, whenever you are going through any question which involve either electrostatics or magnetism and work done to be calculated, in that case, the first thing that should come in your mind is basically the law of conservation of energy or the value of the potential change. So in this case, I'm going to go with the process which includes the change in potential. That was basically the idea of defining the potential in gravitation as well as in electrostatics. If you remember, say in this case, first let me tell you how the situation is. So if I have these two rings which are identical in shape and are separated by the distance that is equal to r. Yes, this has to be a little more closer actually, and both of them have the radius r. This ring has a charge q1, this ring has a charge q2, and say from this point, that is O2 to O1, we are going to take the charge small q and will be needing to calculate the amount of work which will be done by the external agent. So guys, coming back, why do we define the potential is basically to calculate the amount of change in potential energy or the work which is done by the external agent, which we calculate as Q times delta V, and that is what we are going to do here in this question when we are going to find out what exactly is the value of the change in potential and then effectively the work which is done by the external agent. So in this question guys, we need to find out the potential of the initial point and the potential of the final point. So let's start working. Let's first write down the potential of the first ring. Let's call it V1, and that will be K Q1 by R because of its own charge. But because there is surrounding charge of the other ring, you can see that the entire charge of this ring Q2 is lying on the periphery of the ring, which means what? If I take any of those points and join it with the center O1, that distance will come out to be root 2r, because this is r and this is r, so right angle triangle gives me the hypotenuse root 2r. Writing the potential now, so that will be K Q2 by root 2r. You can take K by r common, and in the bracket you will have Q1 plus Q2 by root 2. Okay guys, and if we do the same to find out the potential of the other ring, this time you will have K by R, but in bracket you will have Q2 plus Q1 by root 2. Okay guys, so now what is happening, we are taking the charge say from O2 to O1. You can do the other way around also, you will basically get the answer with the other opposite sign there. So what we are going to do now, we are going to calculate the change in potential, which we are saying is final minus initial. Final is the point 1 and second initial was the point that was O2. Okay, so let's go ahead. So we will have K by R coming out to be common, and I'm going to subtract final by initial. That means Q1 minus Q2 will happen, and Q by root 2 minus Q1 by root 2 will happen. So in order to take care of that. I'm writing it as minus so that I can write Q1 first. So it is Q1 by root 2 plus Q2 by root 2. So that's why putting up a bracket and writing it this way. Okay. So what we have here is this expression, which is whole this thing divided by root 2. Okay guys, you can see that if I take this minus sign inside, it will be Q2 minus Q1 as it is supposed to be. Now what you can do, you can take this Q1 minus Q2 out of this bracket. So you can calculate the value of potential as writing the K as 1 upon 4 pi epsilon naught R, and we are taking Q1 minus Q2 out of the bracket. So this is Q1 minus Q2, and what you will be left with inside the bracket is 1 minus 1 by root 2, which can be seen as root 2 minus 1 by root 2. Okay guys, so this is delta V. So to calculate the work done, all you have to do is multiply this potential difference, work done by external agent obviously, yeah. So multiplying it by Q, the delta V value. So what you get here guys is Q1 minus Q2 multiplied with small q, and this is 4 root 2 pi epsilon naught R, and here root 2 minus 1. And this, my dear friends, is basically the answer. Let's see which option is matching with this one. Okay, so just for options to be visible, let me just rub this part here. Okay, so what do you see? Okay, option is obviously not A, it is not C and D also, because they have Q1 plus Q2. Look at option B. It is Q, small q, Q1 minus Q2, root 2 minus 1 upon 4 root 2 pi epsilon naught R. And yes, we have got the answer as option B. Okay guys, so what you have learned here, that whenever we have to calculate the work done, if it is not a very simplistic situation usually, then if there are extended objects involved, go for finding the value of the change in potential, and at the end you will be multiplying the value of the charge also. You can actually directly start with the potential energy also. It is just that you will be writing everywhere small q in all the terms here. So instead of writing that, I'm just at the end multiplying the value of potential change with the value of the charge to get the answer. Okay guys, hope you like the question. Let's move on to the next question guys. Okay, so the next question, before that, I have a very important information for all of you here. Yes, what does it say? That just like the topics which you are solving in by parts here, sometimes what happens when we are preparing, when we are solving, sometimes we like a subject, but there are chapters which we are not very good at in a particular subject. For example, like when I was a student, I used to think that rotation is a very challenging chapter. So if individually you are interested in just studying rotation, getting all the important questions, previous year examination, and appear for the test related to that topic, so that that topic can also come into your strengths, then guys, we have just the kind of solution for all of you, and what we call them is basically our micro courses. So what you can do, you can master a specific chapter, a particular chapter. You can prepare for any competitive examination with the help of all of those individual tailor-made topics, the chapters that you want to prepare for. And what it also gives you is live learning from the experts of the master teaching here at Vedantu, including me. And yes, you get all the problems which are related to those chapters which you want to score in a given examination. Apart from that, yes, unlimited doubts and the test series. So guys, if you want to go for that, all you have to do is follow this link. And on that link, what you have to do, this is very important for you to remember, you have to put this coupon code over there. This code is SHMIC. When you will be using this code, the course fees will be reduced by 95%. A huge discount is available as of now on all the micro courses with us. Okay guys, so do take advantage of that. Go for the micro courses, whichever chapter you want to study. Okay, so come on guys, let's go forward again. We have the next question, which is from JEE 2002, and what you see on your screen is basically a diagram of capacitor that is filled with 3 dielectrics, that is K1, K2 and K3 as per the diagram which is given to us. So what you see here, that there are K1 and K2 which have area of cross section A by 2 and A by 2, separation is D by 2, and the other one K3 has a separation D by 2 again, rather the width, and the area is A. What we have to do, we have to find out the net value of the dielectric constant of the equivalent capacitor which will replace this capacitor. Okay guys, so let's go forward and try to solve this. So usually whenever you are going to approach a question which involves multiple dielectrics, all you need to do is to consider the possible different types of capacitors which are there. So because the power connection is coming from here, so you can see that the charge or the current will be flowing in this direction. That means what? K1 and K2 are connected in parallel with K3 being in series. So you can draw the equivalent circuit diagram in this manner. Okay. So this is how the equivalent diagram should look to you. Okay. So let's call it C1, let's call it C2, and this is C3. So we'll find out the value of C1, C2 and C3. We'll add C1 and C2 in parallel. We'll add their resultant with C3 which is connected in series with them. So guys, we know that capacitance formula in general without any dielectric is A epsilon naught by D, and with a dielectric the formula becomes A epsilon naught K by D. This is when the entire gap of the capacitor is being filled with the single dielectric K. So in this case guys, what will happen? C1, as you can see, the area is A by 2, will be A by 2 epsilon naught K1 divided by D by 2. So this 2 and 2 get cancelled. What you get is A epsilon naught K1 by D. Can I say that similar thing will happen for C2? So C2 will be A epsilon naught K2 by D. By putting up the value, you can check that as well. And C3 guys, C3 has area different, that is entirely A. So this is A epsilon naught K3 by D by 2, which makes it 2 times A epsilon naught K3 by D. So now we have all the capacitors together. So first, if I calculate C12, that will be C1 plus C2, because capacitors are connected in parallel. You can see that in the circuit diagram. So what we'll have is A epsilon naught by D K1 plus K2 as the equivalent capacitance. And now when you will go for the effective equivalent of the circuit, then the 1 upon C epsilon naught value, 1 upon C equivalent value will be equal to 1 upon C12 plus 1 upon C3. Why? Because their equivalent is connected in series with C3. So let's do that. Put the values here. So C12, we have to put the reciprocal. So D by A epsilon naught K1 plus K2. And the other one, you can see this one, is D by A epsilon naught to K3. Okay guys, and if you compare it with the equivalent capacitance, which is supposed to be D upon A epsilon naught K equivalent, then what you can say, that 1 upon K equivalent guys, you can compare that. D by A epsilon naught is same across. So 1 upon K equivalent is 1 upon K1 plus K2 plus 1 upon 2 times K3. And this should be the answer. Let's see if we have that in the option. Well, if you will check, option B is again matching here. That is 1 upon K1 plus K2 plus 1 upon 2 times K3. Okay guys, so whenever multiple dielectrics are available, you have to basically draw a very simple circuit diagram. Look which of these are in series, which of them are in parallel. Accordingly go by the process and find out the value of the equivalent capacitance. You will be able to calculate equivalent capacitance, or if you want to find out the equivalent dielectric, you will be able to calculate that. Okay, hope you like the question. Let's go for the next one. Okay, now one of the questions which is feared by many students. Yes, the one which includes an infinite ladder of resistance. This question can also be formed with the infinite ladder of capacitors as well. Well guys, so the question which is there in front of you says that you have a battery of 6 volts. This is basically a 6 volt battery, and the 6 volts battery is providing current or the power or energy to a ladder of series of resistances, and the pattern is repeating for an infinite distance. we want to find out what is the value of the effective resistance between A and B, and they are asking us to prove that that value is going to be 2 ohms. Okay guys, so if you do not know this so far, listen to this very carefully. Whenever you are dealing with a ladder which is infinite and repeating, in such cases, if you leave the first branch or first repetition, if you leave, say you consider a point here and here, means this is the part which is repeating. You can see that inverted L part is repeating. So if I call this point as C and this point as D, after this also exactly infinite number of resistance in the same pattern are getting repeated. That simply means what? If I will, instead of removing A and B, if I remove A and B and I put the battery here, then also the value of the equivalent resistance should not change. That's basically the whole idea of finding the equivalent resistance for an infinite ladder. What did I say? If you leave the first repetition and you consider any 2 points and you say that even if I connect the battery there, you can see that the circuit is effectively the same. So the equivalent resistance will still come out to be the same. That means what? When you are saying that if this is what the equivalent circuit should look like, this is your battery, this is point A and B, and R equivalent is going to be your answer, then if you do this also, this is point A, this is point B, and what we are saying that this point is C and D, so this can also be considered as C and D. So what you had here, this entire C to D resistance should also be equal to your R equivalent value, and this is 2 and this is 1 in this case. Okay guys, so the resistance equivalent between A and B and between C and D are going to be equal. So when you are approaching such questions, guys, pay attention to this now. You have to draw the diagram like this. Consider the first branch there with the battery, and for the remaining part, just write down the R equivalent value which you are expecting it to be. Let's say that we are expecting the resistance equivalent value to be R. Okay, and in this case, now what you see, guys, that between A and B also the equivalent resistance is going to be R. So if I consider this entire thing and I'm going to replace it with this battery again, I'm saying that I'm going to get the same equivalent resistance. That means what, guys? We are saying that RAB has to be equal to R. And now when you look at this part here, you can see that, just for you to easily able to decipher this, you can see that R and 2 are connected in parallel and their equivalent is connected in series with 1. That means 1 is connected in series with the equivalent of 2 and R, which will be 2R divided by 2 plus R, R1 R2 upon R1 plus R2, and this is equivalent to the value of the resistance that we are looking for. So guys, now you just have to simplify this. After this, it's a very simple question. So this is 2 plus R plus 2R divided by 2 plus R. Take this to this side, you will have 2R plus R square equal to 2 plus 3R. And now what? Just try to rearrange it. This is R square minus 3R plus 2R will be R, and minus 2 equal to 0. And usually such question will land up to a quadratic equation. Let's just simplify this. So this is R square minus 2R plus R minus 2 equal to 0, because minus R will come because of this part. Can you see that? Okay, so here now I can say it as R taken common, R minus 2 plus 1 taken common, R minus 2 equal to 0. Okay, which means what? Either R minus 2 equal to 0 or R plus 1 equal to 0. R plus 1 equal to 0 will give you minus 1, which is not possible for a resistance. That's why the equivalent resistance between A and B comes out to be 2 ohms as expected. That's what the question wanted us to find out. And yes, telling you again that whenever an infinite ladder is there, you have to consider after the first branch, everything else is basically the same resistance as you're expecting it to be between the 2 points where you're supposed to find it out. Okay guys, so from now onwards you should be able to crack any question which involve an infinite ladder. Okay, hope you like the question. Moving on. Now this one is a question which looks like from a transient current circuit, because here we have a resistor and a capacitor involved. What is the transient current circuit? The circuit where once the capacitor starts to get charged, the current in the circuit starts to grow, and when it decays, that means when it discharges, the current also decays with time, which simply means what? The current will not be a constant value current, especially during the time when the capacitor is getting charged and discharged. So guys, in this question, what the question is saying, that when you are closing down this switch S, the capacitor, which is initially uncharged at t equal to 0, so we have to find out once the charging starts to happen, so after a time t, how much amount of charge will appear on the capacitor. Okay, so we have to find out the value of the charge here, guys. So guys, at t equal to 0, remember these 2 points that I'm going to tell you. So at t equal to 0, your capacitor will behave like a straight wire. Remember this. Why? Because it does not have any charge, so it does not have any potential, so it is basically not going to offer any resistance towards the flow of current. And once the capacitor gets completely charged, say that time is infinity, so at that point of time, the capacitor in the circuit will break the circuit. Okay, means what? The branch in which capacitor is there, you can consider that branch not to be there in the circuit. Okay guys, so now what? Situation starts with t equal to 0 and goes only till t equal to t, so this situation will not arise. And what we will be talking about, so let's talk about t equal to 0 first. So when we are speaking about t equal to 0, guys, what is the equivalent circuit at t equal to 0? T equal to 0 will have this capacitor behaving like a straight wire. Yes, at t equal to 0, when the capacitor has no charge, it will start behaving like a wire. That means what? Your equivalent circuit after closing down the switch just at that t equal to 0 moment will have this switch closing down. You have this resistance here, and there is one more resistance here, and this resistance is also in this branch. For our easy understanding, let me draw this here. Okay, so what we have, R, R and R connected to V. This is happening at t equal to 0. So you can see that these two are in parallel and then in series with this one. So if you calculate R equivalent will be R plus the equivalent of this, which is R by 2. That means, guys, this will be 3R by 2. So guys, if we want to find out the value of charge on the capacitor at a time t, we know that the charge which it can maximum get at t equal to infinity, say that charge is going to be Q naught. So at any given point of time, the equation is written as Q equal to Q naught 1 minus e to the power minus t by tau, where tau is basically equal to the product of the resistance and the capacitor. Means what? This is basically that time which is called as the time constant. Okay guys, so now if we are going to talk about the value of tau, so tau can be calculated as R equivalent times C. Okay, so tau equal to R equivalent times C is basically 3R by 2 times C. So 3 by 2 RC is your equivalent time. That means what, guys? Now at steady state, so once the steady state has achieved, why do I need this? So that I can get the value of Q naught. So what is at steady state time? That is when t has reached infinity and capacitor has now blocked your circuit. So when the capacitor will block the circuit, guys, basically your equivalent circuit will be only this much. Means what? Now you have a voltage of the battery which is getting dropped on two equal resistors. So equal voltage will be dropped on equal resistor here. So what we can say, that the amount of voltage that is being dropped, say on this point, let me call this point as A, we can say that VAB will be equal to voltage on the capacitor. Okay, So voltage on the capacitor, let's call it VC, will be equal to capital Q naught by C, because Q naught is equal to CV, and we know that this value is going to be how much? V by 2 on this one and V by 2 on this one. So this and this are same, so let's equate it as V by 2. So the maximum possible charge which can come on the capacitor is CV by 2. So now we have the value of Q naught, we have the value of tau. We can write the expression for the charge after a time interval t as CV by 2 1 minus e to the power minus t by tau, and this tau value is 3RC by 2. So 1 upon tau value will give you 2t by 3RC. Okay guys, so now what we have is our final answer as CV by 2 1 minus e to the power minus 2t by 3RC. Let's check whether that answer is correct or not. Okay, no options are there. This is a subjective question. So this basically is the answer to this question, that is CV by 2 in bracket 1 minus e to the power minus 2t by 3RC. Okay guys, so now in transient current, all you have to remember what the capacitor does at t equal to 0. It behaves like a wire. What it does at t equal to infinity, it gets completely charged and blocks the branch in which it is connected, and its potential will be equal to the branch that is parallel to it. So it will help you calculate the value of the charge it has got at t equal to infinity. And remember, this is the amount of charge that it gets stored on the capacitor during its charging. And when it is discharging, in that case, the expression is Q naught times e to the power minus t by tau. Okay guys, hope you like the question. Moving on to the next one. Okay, so now this one is from magnetism, and what you see here on the screen guys is basically a circuit which says that you have a battery which is supplying current to a ring type of structure of a conductor, and the ring type of structure has a radius r and the entire resistance is capital R. Okay, so what is given here is basically that branch AB, after the current reaches point A, it follows Kirchhoff's junction rule and the current splits into I1 and I2. When it comes here, again I1 plus I2, that is I, goes to the battery. So what is happening here, you can see that the direction of current and the magnitude of current in this section, that is smaller section, it is looking like it is anti-clockwise, and for the part that is the bigger section here, the current is different and is moving in a clockwise fashion. So we have to find out the value of the magnetic induction because of the two currents and the segments there at the center due to I1 and I2. Information that is given to us is that this angle AOB is equal to theta. So guys, we know that whenever the current is moving in the circular fashion, then you have to use your right hand thumb rule, curl your fingers in the direction of the current, the thumb will give you the direction of the magnetic field. So if I say that this is the current which is moving in clockwise direction, my thumb is pointing towards the direction that is going into the plane of this board. That means for I2, the direction of magnetic field is cross, which is going inside. And obviously for the other one, the direction of current is just opposite. In that case, what you will be doing, you'll be basically talking about the direction of current which is going like this, and the magnetic field is coming towards you, that is dot. So let's try to find out the value of the magnetic fields because of individual things, and we'll find out which of these options are suiting to get the value of the net magnetic field at the center of this ring. Okay guys, so this is the diagram that we have here. Let me try to write the values of B1 and B2. So if we write B1 vector, then B1 will have a value that is mu naught I1 by 2r, which is the radius, times theta upon 2 pi. You know that for an entire ring, this theta will be equal to 2 pi. So 2 pi by 2 pi cancel, and the expression comes out to be mu naught I by 2r. Okay guys, so As of now, we do not know the value of I1, we do not know the value of the resistance also, so that's why we do not know the value of I1 even if we know the value of the potential of the battery. So I1, I2 values are not given. In fact, if you look at the options, the options are not in terms of the current here. Okay, so we'll have to work out the value of the currents. Okay, so moving on, let me write the value for B2 again. B1 we have already written, so this one will be mu naught I2 by 2r multiplied by the remaining angle, which is this one, which is 2 pi minus theta upon 2 pi. So these are the values of the magnetic fields. Those are B1 and B2. Guys, let's try to find out the value of I1 and I2. Now what you see here, that the current when it is reaching point A is getting branched out. So can I say that AB and the other section, let's call this point as C and this point as D for our understanding. Can I say that ADB section and ACB section, they are both connected for the same potential difference, which is the battery. That means the lower section ACB and the upper section ADB, they are connected in parallel. That means they have the same value of potential drop happening at them. So I can say that E is same for both of them. So I can write I1 R1 is equal to I2 R2. So calling this section to have a resistance, that is R1, and this section to have a resistance R2. Okay guys, that means what? The value of I1 by I2 is going to be, or rather if we say that these values are equal to E, then I can say that I1 will be equal to E by R1, and that is what? We know that the resistance is equal to rho L by A. So if we start writing the proportionality here guys, then can I say that this will be proportional to 1 upon resistance, which is rho L by A. Rho is same for entire wire, area of cross section is same, so it will be directly dependent upon this section length. Can I say that the arc angle is defined as the arc length divided by the radius? That means this arc length which we are interested in finding is equal to r theta. So let me write this as r theta. Okay, so the entire value I'm writing it as k by r theta here, that is I1. And if we do that same for I2, then I2 is E by R2 and is proportional to 1 upon the remaining length, and that remaining length is going to be R times 2 pi minus theta with the same logic. Okay, so now what? I'm going to put the values of I1 and I2 and we'll be finding the value of B1 and B2. So guys, going back there, putting up the value of I1 here. So B1 comes out to be mu naught. I1 is k by r theta. So I have 2r, r theta comes here into theta by 2 pi. And if you can see this in the diagram here guys, for B1, the magnetic field has a direction that is coming towards you. So let me write it as dot coming towards you here. Okay guys, so what you see here, that theta gets cancelled with theta. So B1 comes out to be mu naught k by 4 pi r square. Okay, and let's do the same for B2. For that I'll have to put the value of I2 here. So I have mu naught, I2 value is k by r times 2 pi minus theta. So mu naught upon 2r is already there, putting r upon 2 pi minus theta and multiplied by 2 pi minus theta upon 2 pi. Okay, so you see that this 2 pi minus theta gets cancelled, and what we get, B2, also the direction is going to be inside. That means this is cross. Okay, so guys, what we get here is mu naught k upon 2 into 2, 4 r square pi. That means 4 pi r square, and when this vector was a dot, this one is a cross. And what do you see guys here? You see that B1 vector is equal to minus of B2 vector. They are just opposite vectors of each other, and hence what can we say that for any value of theta, the net magnetic field at the center of this ring will come out to be 0 for any value of theta. So that's going to be our answer for this question, which is option B, guys. Okay, so I hope that you enjoyed all the questions which we have solved today. We have solved killer 5 questions from electrodynamics, and guys, if you guys are having fun with us, then what, I have one more news to share with you all. Yes, thanks to all of you guys. You guys have made our Vedantu's app as one of the best app of 2019. Thank you so much for giving us the User's Choice Award for 2019, guys. For those of you who are still not there on Vedantu, you guys are missing out on a lot. So this is your golden opportunity. Go on the Play Store of your phone, download this app and take the advantage of all the content that we have, including the micro courses which I was speaking about, guys. So guys, this brings us to the end of this session. If you have not, then like, share, subscribe this channel to get all the information, not to miss out on any important video that we keep on releasing. Tell your friends if they are not aware, subscribe to the channel if you have not. And one more important thing, all the contents which are related to electrodynamics, which as I told you is from electrostatics till everything that is related to magnetism, the link for all the micro courses is there in the description below of this video. So do take advantage of that and keep coming for the another session of the Killer 5. Thank you guys. I'll see you guys again. Bye-bye.